Hi, welcome to Physics 5.3 video number 2. All right, so we're going to start with charts and equations. So anytime that you're given a problem, either written or picture, you're going to start by doing an energy chart and energy equation. So in this example, this is a pullback car. I've labeled the positions A, B, C, D, E from left to right. At position A, the car has been pulled back, wound up, and is ready to let go. So what kind of energy do we have? Hopefully you said elastic, because that's what's in there. It's a spring. At position B, it's gaining its speed, and at E, it's going to be going the fastest that it will go. Okay? So in order to make a bar graph, the easiest way to make a bar graph is to use a table. So you insert a table, and you can do that in a Google Doc. You can even do that in a text box when I give you a Canvas text box entry. You need 5 rows, right? Because the most energy you can have is 4 blocks. You need 5 rows and at least 2 columns for each location. If you have more than 2 kinds of energy at each location, right? And in this problem, we only had 2. We had elastic and we had kinetic because it's not slowing down, so we don't have thermal. So you're going to label the bottom and then you're going to shade the columns. This is what it looks like in the end, but I want to show you how to make that, okay? So if I show you how to make that, you're going to go up here to Insert, a Table. You need 5 rows down and at least 10 columns because I have 5 positions, okay? You label that bottom row. So looking back at your picture, right here, looking back at your picture, I know I had EEL at A, I had EEL at B, and EK at B. I had EEL at C and EK at C. I had EEL at D and EK at D. And then I just had EK at E. The spring has sprung, so I don't have any more spring energy. So in this one, I don't really need these last 2 columns. You just go here to format your table and you can delete those 2 columns because you don't really need them. Then in order to color it in, you literally highlight the blocks that you want and you go up here to this little paint bucket and you fill it. And if I make my EEL blue, right, maybe I'm going to have 3 blue here, and the elastic energy is going to decrease each time. So maybe at C, I only have 2 that are blue, and at D, I only have 1 that's blue. Okay. Then my EKs, they're going to get bigger because I'm speeding up as I'm going through this. So maybe I'm going to make those red, my EK at B, and maybe I have 2, because remember the max you can have is 4. So at D, I would have 3, and at E, I would have all 4 blocks of EK. Okay, now on mine, I shaded these in, or I made this be a white background so that you could see it easier, but you won't have to do that on yours because it'll be a white background already. Okay, so this is the final product. Notice that my EEL is red, my EK is yellow, but it is the same as the one I just made with you. Okay. Then we want that energy equation. And the energy equation is literally the bottom of the bar graph with equal signs between the locations and plus signs at the same location. So it reads EEL at A equals the EEL at B plus the EK at B equals the EEL at C plus the EK at C equals the EEL at D plus the EK at D equals the EK at E. I know it's a mouthful. So, moving past that to calculations, if we knew that at location B, the 20 kilogram car was going 1 meter per second and E was going 7 meters per second, then we can calculate. And you always start with the location that you have a total energy. So I have everything I need for position E. The EK at E is 1/2 mv squared, which is half of the mass, which is 20, times 7 squared, which is 490 joules. That means, based on that energy equation, the EK at E is equal to the EEL at A. That's what those equal signs mean. They're the same. So that means that we also know the EEL at A is 490 joules. So what about a mixed location? Well, at position B, we know it's moving at 1 meter per second. So I can find the EK at B using my EK equation. Therefore, using subtraction, I can find the EEL at B because each location has to have a total of 490. I'm going to give you a couple problems to do to finish up 5.3. Thanks for watching.